Imagine watching a colossal rocket booster, one of the most ambitious ever built, hovering momentarily before dramatically plunging into the ocean depths. That's precisely what happened during SpaceX's recent Starship test launch, and the footage is nothing short of breathtaking. But here's where it gets controversial. Some argue that these splashdowns are wasteful and create unnecessary ocean pollution, while others see them as a necessary step in the rapid development of reusable space technology. What do you think? SpaceX, the pioneering space exploration company, conducted the 11th test flight of its gigantic Starship rocket on October 12th, achieving all planned objectives. This test was a crucial milestone in the ongoing development of a fully reusable space transportation system. The Starship vehicle consists of two main parts: the ship, which is the upper stage designed to carry cargo and eventually passengers, and the Super Heavy booster, the powerful engine that propels the entire stack into orbit. Together, this dynamic duo stands an impressive 400 feet, 122 meters tall, and SpaceX isn't stopping there. They're already planning a taller, upgraded version, the V3 iteration. Indicating their commitment to continuous improvement, the Starship V2, which launched from SpaceX's Starbase facility in South Texas on Monday, October 13th, had faced challenges in previous test flights. However, Flight Test 11, along with its predecessor, seems to have redeemed the rocket, showcasing significant progress in its final flights. To highlight this achievement, SpaceX released a captivating video showcasing the Super Heavy booster's final thrilling moments before its controlled descent into the Gulf of Mexico. You can find the video on X, formerly Twitter, at https://x.com/SpaceX status 197855639155750 https://x.com/status 197855563915750. Flight Test 11 not only met all its mission goals, but also demonstrated improvements over Flight Test 10. In the previous test, the ship upper stage experienced visible structural damage during its fiery re-entry through Earth's atmosphere. This time, the design and operational adjustments seem to have paid off, leading to a much smoother and controlled descent. And this is the part most people miss. The atmospheric re-entry is one of the most challenging aspects of spaceflight, requiring robust thermal protection and precise maneuvering to avoid catastrophic failure. The ship's descent and soft landing in the Indian Ocean provided a stunning conclusion to the V2's final flight, roughly an hour after liftoff. The Super Heavy booster, on the other hand, completed its mission approximately 6.5 minutes into the flight. This particular Super Heavy booster had flown once before, making it only the second booster to be reused as part of SpaceX's ambitious goal to make Starship fully reusable. This reusability is absolutely critical to the long-term viability of space travel, significantly reducing costs and enabling more frequent launches. Starship is the cornerstone of SpaceX's vision to establish a permanent human presence on Mars. Elon Musk, the CEO of SpaceX, estimates that achieving this ambitious goal will require over 1,000 launches. This is where reusability becomes paramount. The ability to land and relaunch the Starship vehicle repeatedly is essential. NASA has also recognized Starship's potential, selecting it as the lunar lander for the upcoming Artemis 3 mission. Artemis 3 aims to return astronauts to the moon's surface for the first time since the Apollo missions of the 1960s and 70s. With NASA targeting a launch date sometime in 2027, the pressure is on SpaceX to make Starship fully operational within a relatively short time frame. Beyond the successful splashdowns of both the ship and Super Heavy, Flight 11 also achieved several other significant milestones. These included the deployment of Starlink mass simulator satellites, essentially dummies used to test the deployment mechanism. the relighting of the ship's Raptor engines while in space, and a new engine burn initiation sequence for the Super Heavy booster during its deceleration and landing burn. These achievements demonstrate the increasing sophistication and reliability of the Starship system. While both Super Heavy and Ship are designed to eventually return to Starbase for rapid turnaround and reuse, neither stage was recovered in this particular test. SpaceX has successfully caught Super Heavy 3 times using the giant mechanical arms attached to the launch tower, often referred to as the Mechazilla chopstick arms. The ship upper stage is also designed to be caught by these arms, although Elon Musk has indicated that SpaceX's first attempt to do so will likely occur in early 2026. This catch system represents a radical departure from traditional rocket recovery methods and could revolutionize spaceflight. So, what are your thoughts on SpaceX's progress with Starship? Are the splashdowns a necessary evil, or should they be avoided? And what do you think about the timeline for achieving full reusability and landing the ship using Mechazilla? Share your opinions in the comments below.